Depending on the emission scenario that we choose to follow, the temperature increase by 2100 will vary anywhere from 1 to 4 degrees Celsius. The amount of warming that will occur will determine the possible effects. Remember, keeping temperatures below 1.5 degrees C will help us to avoid dangerous impacts. Important to keep in mind is that warming will not be the same everywhere. These maps show how temperatures will vary across the globe under different scenarios and for two time periods, 2020 to 2029 and 2090 to 2099. Notice that the greatest heating is over land and particularly at northern latitudes. In Canada, the north will be the most impacted. This slide shows warming in North America, first from 1901 to 2012, and then for the future. Again, notice how the north will warm the most. Also notice that the Great Lakes region is projected to warm by 50% more than the global mean warming. So far, we have focused on how global or regional means will change. But what may be more important are the extremes. This is because it is during extreme conditions when impacts will be most severe. The top panel shows that if we increase the mean, we also increase the probability of extreme days. For example, days with temperatures greater than 30 degrees Celsius. However, we also decrease the number of cold days. The second panel shows what happens if we increase the variability of climate but keep the mean the same. Again, we increase the number of extreme days. With global warming, it is predicted that both the mean and the variability of climate will increase. In the bottom panel, we see that increasing the mean and the variability will increase considerably days with extreme conditions. This is really important to keep in mind as we move forward. Climate models show that cold days will decrease, but warm days, and in particular extremely warm days, will increase. This is particularly true for the emission scenario RCP 8.5. This means that we can expect the duration, intensity, and spatial extent of heat waves to increase in the future. A nice example of what I'm talking about comes from the Ministry of Environment, 2009. This slide shows the number of days that are expected to be above 30 degrees in Toronto. By 2050, we can expect the number of days above 30 to be close to 40 days. This has implications for health, energy use, water quality, and many other important factors. The IPCC is quite confident in scientists' projections of temperature change, but modeling precipitation is much more complex. This image shows how precipitation is expected to change with a warming of 3 degrees Celsius. Which regions get wetter? Which regions get drier? These IPCC images show changes in precipitation from 1986 to 2005 and from 2081 to 2100 for RCP 2.6 and RCP 8.5. The equator and Arctic get wetter, while the subtropics become much drier. Note that areas with hatch markings indicate areas where projections are less certain. Although the patterns are similar for scenarios, the amount of change is much less for the RCP 2.6. Also note that there is much more uncertainty in the precipitation projections than those for temperature. Recall from last week that we saw how drought has had a devastating impact on human societies. Drought is really a measure of moisture availability, or precipitation minus evaporation. In a warming world, the hydrologic cycle is intensified so that both precipitation and evaporation increase globally. These slides provide estimates of how precipitation, left panel, and precipitation minus evaporation, or drought, on the right panel, vary with latitude between 2016 and 2035. It is clear in the right panel that equatorial regions will become much wetter, whereas the subtropics will become much drier and more susceptible to drought. These maps show how precipitation change is expected to occur in North America. Most of Canada is predicted to become somewhat wetter, including the Great Lakes region, but the percentage of change is much greater following RCP 8.5 relative to the RCP 2.6 scenario. Of course, these predictions are quite uncertain. Important to understanding global change in precipitation is understanding how monsoons will change with climate warming. Recall, monsoons are caused by differences in land-water heating. In the summer, increased heating over land draws moist air inlands from the sea, causing precipitation. In winter, greater cooling of land causes winds to reverse. The lower map here indicates monsoonal areas in pink, and the different colors of blue and green show the magnitude of extreme events. Note that monsoonal regions have more extreme events. Also note in the upper map that monsoonal regions have a large proportion of the world's population. In fact, 2/3 of the world's population and almost all of the world's impoverished live in monsoonal areas. Therefore, it is critical for us to understand how monsoons will change, how precipitation will change in these areas. A review of recent literature indicates that warming will cause a later start in monsoons, increased seasonality of precipitation in monsoonal areas, an overall reduction in the length of the monsoon season, and an increase in extreme events in monsoonal areas. But what does this mean for the people living in these areas? It isn't an easy question to answer. Let's take a look at India as an example. Monsoons deliver 70% of the total rainfall in 3 months in India. 60% of India's agriculture is rain-fed. Nowhere else in the world is a population so dependent on seasonal rain. Thus, there is a great urgency to understand how global warming will affect monsoons in this region. Warming oceans should increase evaporation, meaning monsoonal winds would carry more moisture inland. However, for complex reasons that include not only global warming, but local pollution and landscape changes, oceans are heating more than land, weakening monsoon circulation and overall delivering less moisture. This slide shows precipitation in India on the left and changes in precipitation in extreme rainfalls on the right. Some places in India have become wetter, shown in blue, and some drier, shown in brown. Many areas are experiencing more frequent extreme rainfall events. Based on models, overall precipitation will likely decline in India. Monsoonal precipitation will be delivered in shorter and more intense periods. This means India could suffer both droughts and flooding. The availability of clean water in India as temperatures continue to increase is tenuous and should be of paramount concern for the future.